I'm Santiago. I'm the technical product owner of an API platform that is built on top of AWS, and we have scaled it multi-region. I will tell you a little bit more about that. So, Volkswagen Financial Services. If you own or if you have purchased any of these brands that you are seeing here, and you have leased the car, or if you have financed it, there is a 99% probability that your contract landed on our desk, right? So, we are a company that is part of the Volkswagen Group, and we are basically providing financial services to the group for all the brands that you see here on the lower side of the slide. And the traditional way of closing contracts with our customer has always been our customer wants to buy a Volkswagen, Seat, Skoda, Audi, and so on. They come to the dealer, they purchase a car, they fill the contracts, and those contracts are being sent to us. Now, 5 years ago, we started a digital initiative. Basically, we wanted to digitalize the business processes that we have in our company. And the main goal of digitalizing is basically to complement how we were working traditionally. So instead of having the products in the center of the triangle, we are having the data, the customer data, and then with that data, we are able to assess our customers which are the best possible products that they can buy for their cars. And we have done this for multiple markets. And we had one main goal, which is to sell 2.5 million contracts until the end of 2025. So far, we are in 29 markets. We have more than 10 products online. That means financing, leasing, motor insurance, even leasing bicycles. Also the customer portal, and so on. We have more than 80 live applications around the globe in different markets. We have closed in the last year more than 900,000 contracts, and we do it for all the brands. So when we speak about scaling, scaling for us is not only about how many users can we serve at a single point in time. Scaling for us is how can we get as many applications as possible in as many markets as possible so that we can minimize the time to market to our end customers. Because at the end of the day, we want to sell as many contracts as possible. And that type of scaling is only possible when we establish standardization. So we have standardized, basically in our company, how we are building and how we are shipping applications. The first thing that we have standardized is our public cloud provider. So we are using Amazon Web Service as our runtime. Of course, we have a multi-cloud. Yeah, we have on-prem, but at least for these digital applications, we are running them on top of AWS. We have standardized how we are organizing the teams. We have platform teams that are responsible for defining which are the technologies that we are in use and which are the standards, how applications, how APIs should be developed. We have a platform team that is ensuring that our public cloud is as compliant as possible. Because at the end of the day, we are a financial institution that is operating in Germany. We have standardized which development tools are being provided to developers, to engineers. For example, CI/CD pipelines, JFrog, GitHub, and so on and so forth. And when it comes to the application itself, we have standardized how frontends are being built, how APIs are being built, and also how data is being processed. And today I will focus on APIs. So how many of you have been consuming APIs? How many of you have ever consumed an API? Great. How many of you have built an API? Awesome, perfect. So APIs are basically a way to integrate systems. In our domain, we mainly use RESTful APIs. And we started by standardizing how APIs are being built and how the development cycle for APIs actually look like. So we always start with an open API. We have an open API first approach. During the design phase, we expect an open API document to be ready. During the generate phase, we have built in-house a tool that is mainly taking that open API specification and is generating a microservice, a Node.js server that is actually running in a local environment. The responsibility of the API engineer is actually to implement the business logic in the API. Once that business logic is implemented in the API and is running locally, and he's happy about how it's running locally, then it's time to deploy it. And we also develop an in-house tool that is mainly generating how that API is being deployed, and also is taking away the responsibility from the engineer in terms of how am I deploying it in AWS, which type of AWS service I am going to deploy, and how should I configure that AWS service in order to be compliant. Because as I said before, we are a financial institution. Once that API is deployed, it's time to publish it in the API platform. And we publish it in our API management solution, which is Kong. And once it's published, it's publicly accessible. And it's time to monitor it. And we are using Datadog for it. Now, that was the development cycle. Now, how is our deployment model? We follow one fundamental principle, which is minimizing the blasting radius. So what does that mean? So we want to minimize the risk of having our platform or APIs down. We want to minimize that somebody accidentally is going to one of the stages and is deleting the runtime environment that is hosting our APIs. And believe me, it can happen. It happened to us. Not in production, but it happened to us. Yeah? And our architecture has the following principle. Each and every API has its own data center. Each and every API is deployed in its own AWS account. We have a central AWS account, which is mainly for hosting core components of the platform, like the API gateway, the API portal, or some management APIs that we have in our platform. So the APIs are never, ever running in the same AWS account. They are running in the AWS account that is belonging to that specific project, that specific product. And we were able to grow to 140 APIs in a matter of 1.5 years in more than 100 AWS accounts. We are operating in 6 AWS regions, like Frankfurt, Sydney, US, Canada, and so on. For each and every API, we have 4 stages: development, integration, consolidation, production. And we are offering more than 500, so we are receiving more than 500 million API requests per month. So we have such a distributed ecosystem. So that's actually challenging when you want to have a nice observability or an efficient observability. And that's where Datadog became very handy to us and helped us a lot, because with Datadog we can integrate all those different AWS accounts, all those different systems that we have in isolated data centers into one single tool. One single tool that will help us to do both monitoring and both logging. And will also help us to provide platform dashboards, to be able to share information to different audiences, like business, IT, for example, SLAs, availability times, or to provide a platform dashboard where we are showing the performance of our API platform itself. Or even to go lower in the application stack and be able to troubleshoot at a dashboard level the infrastructure. And we have been shipping this type of dashboard to different target audiences in different ways. Another way that was very, very, very sexy for the business was using the mobile phone, the mobile app of Datadog, so that they can see in real time, on a weekend, for example, they can just refresh, they can have a widget where they can see, hey, my platform is up and running, I can continue with my weekend. So all these kind of things help us to build a DevOps mindset in the organization. But the main aspects that were necessary to do that is first defining a very, very solid tagging strategy. So once we started using Datadog, that was the first list item in our homework. Once you have a very good tagging strategy, you are able to organize your information in Datadog and show it in a very, very efficient way. And what does in the scope of APIs, in the domain of APIs, actually mean to have a very good tagging strategy? So having information about who's the API owner, who's owning that API, which tool has been, and which version of the tool has been used to deploy the API, which is the name of the API. And it was also very good to hear about the service catalog today in the morning, because that's something that we are prepared for that. We already have all that data inside all the metrics and inside all the logs that we are shipping to Datadog so that we can extrapolate it in the form of a service catalog. If you want to increase the adoption of a tool, an observability tool such as Datadog, you really need to do something, and that's automating the rollout of the tool itself. Because if you put that responsibility on engineers, on API engineers that are actually supposed only to develop the API, they're just not going to do it because they don't know or they don't have time for it. So our second point was to automate not only how we are integrating Datadog in this highly distributed ecosystem, but also how we are integrating Datadog when we are developing and delivering APIs. For example, automating the creation of the alarms. We provided as platform teams dashboards in a central way, because the creation of the dashboards can also be a little bit tricky. So we provided them as templates so that other teams that were interested in only observing 2 or 3 APIs, they can copy and paste a widget and they can configure it. We have also created analytical team routines. For example, at the end of each and every team sprint, in a retrospective, for instance. Let's open the dashboard, let's take a look how our platform performed over time. Let's take a look if we need to change something, if we need to change the architecture. And we embedded objectives and key results also in the views of the dashboard. So objectives and key results are typically coming from the management, and usually the engineers are not aware of them. So if you embed them in the dashboard views, then they will be able to know and to understand what's a good performance, what's a bad performance. Now, when it comes to incident management, and when it comes to actually troubleshooting APIs, there were 2 action points that we took, and we defined reactive and proactive alerting in our domain. Reactive alerting means that we are creating alerts so that we can react and we can see in real time when APIs are failing. Proactive means that we want to go 1 step ahead of our customers so that we can actually check in advance if something is failing before our customer is picking up the phone and calling our support desk. So when it comes to reactive alerting, what we are seeing here is a CI/CD pipeline. A CI/CD pipeline of an API that is called Virus Scan Service. It's an API that is basically scanning for viruses. Very typical API that we need in any kind of application where we are handling with any kind of documents from customers. Yeah? So we have embedded in the CI/CD pipelines the automated and standardized creation of alarms. There are 2 types of alarms that we are creating, standard alarms and custom alarms. And because the creation of alarms in Datadog is also not that simple for an engineer to do it at scale, we have created an abstraction layer on top of Datadog. And that means that there is a manifest file that is attached to the API and is saying who should be notified, which is a threshold for both standard and custom alarms. In the case of the custom monitors, we are using log-based patterns. And this specification is then translated in the pipeline to something like this. And then voila, we have an alarm in place that is created automatically under the hood for the API team. It's already tagged, it has a standard query, and it's alerting the API owner if the API is failing. When it comes to proactive monitoring, the OpenAPI specification has become very handy because an OpenAPI specification contains very, very useful information. For example, URL, endpoints, request model, response model, together with examples. And that's basically what you need in order to build multi-step API tests. And by building automatically multi-step API tests, we can proactively, in regular time intervals, monitor if our APIs are failing or not, because we are basically emulating the business logic of the application. So that was the part of alarming and troubleshooting. But another aspect that really helped us to create this DevOps mindset and this efficient way of doing DevOps in the organization, together with the data-driven decisions, is to analyze how we can evolve the architectures over time. And I want to show you two examples here. The first one is related to error handling, and the second one is related to bottlenecks. So when it comes to error handling, what you see here on the screen is basically a dashboard that is measuring the bounce rate for an API that is called mail service. So we have a mail service API. We built a mail service API that is essentially using the AWS simple email service. So there is something a little bit tricky with AWS simple email service, which is the following. If you have a high bounce rate, they will shut down the service. You won't be able to consume the service. And we realized that the hard way. So one day we received an email from our customer support saying, hey, you have a really a high bounce rate. So the first action point for the team was actually to gather the data, consolidate the data, and be able to monitor the data. For example, how many permanent bounces do we have? How many transient bounces we have over time? And also to create alerts over time so that we can take action on it. And that helped us also to communicate to the outside. And when I say the outside, I mean the consumers of that mail service API. Because when our business was consuming that mail service API, they were really expecting that everything will work all the time. And that's just not true. Everything fails all the time. We need always to design our architectures with failure in mind. Another point that we needed to take is that we needed to extend the mail service API with records for the mail bounces. We really needed the data to analyze. We really needed to analyze the data related to which are the mails that are actually bouncing and why. And we also allow the consumers of the mail service API also to redefine and redesign the business processes so that they can consider bounces. They can consider that an email is not always successfully sent. And of course, we provided the email bounces dashboard as a self-service, the one that I showed you before. So another example, which is more common, are the backend bottlenecks. In our case, Volkswagen Financial Services, we have a multi-cloud strategy. So we have some systems that are running on-premise, some systems that are running in multiple clouds, in public clouds. So what you see here is the performance between June and July for an API that is called the media storage service. So the media storage API is meant to store any kind of media, files, videos, and so on and so forth. And because all those files, they need to be cleaned, they all need to be scanned for viruses. And the virus scanner is hosted in our on-prem cloud. So we started seeing this weird behavior. We started seeing that the latency, the P95, went a little bit crazy between June and July. And that triggered basically our alarm so that we can start discussing and we can start troubleshooting what's actually happened, yeah? And which was the outcome of that? That helped us basically to detect an alert when a bottleneck is actually happening. And we also rethought our architecture of the media storage so that we can minimize the dependency that it has with the API that is having a performance detriment. For example, using events, making it asynchronous, using queues. so that we can minimize the latency and we can minimize the impact of using such an API that is having a bad latency. And of course, that triggered the discussion, and it helped us really, really a lot to have the data so that we can start the discussions for migrating the functionality that is causing the bottleneck to a more scalable environment, for example, to a public cloud provider. Now, in the scope of data-driven decision, having the observability data at hand is super handy so that you can decide where you need to invest your budget, how you need to define the objectives in the organization. And I will show you an example here that is based on performance. So we have 3 APIs here. The first one is a various scan service that you know already. You are aware of it. We have a verimi service API, which is mainly used for identification and legitimation. And we also have the mail service API, which you already know. So one of the key learnings, especially when you look at the performance, is that they actually perform very, very differently. So when it comes to defining objectives for APIs, objectives related to performance for the APIs, you cannot really treat them in the same way. You cannot put them all in the same bag. You cannot say that I want to have a latency of XYZ for all the APIs, because that just won't work. Each and every API is domain specific. And that helps us basically a lot to trigger how we are defining the objectives in the organization with regards to APIs. We started categorizing the APIs because they are actually not doing the same. Also, when building OKRs, when building objective key results, you need to consider historical data. They need to be realistic. One of the exercises that we took is also each and every quarter, identify which are the top 5 less performant APIs, so that then we can then trigger our investments there, re-architect them, and make them better. And also providing all this usage information as a self-service, because that will just generate transparency in the organization. Good. Takeaways. The only possibility to increase the adoption of a tool, an observability tool, such as Datadog, in an organization, in our use case in Volkswagen Financial Services, was to standardize and automate how Datadog is being integrated at scale, and also standardize and automate how Datadog is integrated in the scope of APIs. Because remember, we take away most of this type of responsibility from the API engineers. API engineers are supposed only to write the best possible business logic. You need to monitor APIs reactively and proactively. You want to know when something is failing. And potentially, you also want to know when something is failing before your customer is picking up the phone and calling the support desk. Creating routines for analyzing how APIs are performing over time will basically help you to identify which are the APIs that actually need to be re-architected. Develop everything with failure in mind. Architecture will evolve. There is no such a system that is developed and it will stay like that the whole life. Systems need to evolve. And derive the OKRs, objectives in the organization based on historical data, based on observability data, especially when it comes to performance and operations. Our journey with Datadog continues. Being able to have an end-to-end performance observability, including also on-prem backends, is our dream. Being able to integrate it with systems, monitoring systems that we have on-premise, or also potentially having an on-prem deployment of Datadog. Testing data for production is always a pain, but it is possible. We are also very thrilled to start using the real-time API security monitoring to be able to detect threats in real time. And we are also going to integrate Datadog with on-prem incident management systems, mainly because our incident management system runs on-prem. That's all from my side. Thank you very much for your time. Open for questions.
Great. Thank you so much, Santiago. There's a couple mics in the back, and feel free to walk up and ask a question. In the meantime, I got my own couple questions for you. I think the biggest one for me is, what are your biggest challenges when it comes to implementing Datadog? Like, where do you wish things could be improved generally?
So, when integrating Datadog in an ecosystem, in a financial services ecosystem, it's always about compliance.
Okay.
And especially in Germany, it's about PII data.
Okay.
You cannot enforce automatically or automagically that there won't be PII data being shipped to any kind of observability tool. In this case, Datadog is a software as a service, so we need to be super careful about that. So how have we overcome those challenges? First, you always have the manual step of reviewing how the code is being implemented, but that's a little bit expensive. So we started offering, especially for the logs, we started offering a middleware, a logging middleware, that is automating the obfuscation of PII data under the hood for the engineers. And that's basically taking the Open API. As I said before, the Open API specification is super rich. It can be used in a very, very, very good way. And we are starting to use the sensitive data scanner, Datadog, because you cannot ensure 100% that anybody in the organization will write a log line that will ship something to Datadog. So you also need to have that in place so that that team, that API owner, the compliance department can be notified in case that happens.
Gotcha. So being aware of what you're shipping seems to be a challenge. So do you have like a top 3 things that you would recommend for somebody who's going to be observing their APIs in general?
Well, the first part is how you're integrating that observability tool. The less effort you expect the API teams to do, the more you will get. The more you standardize, the better you will be able to aggregate your data and show it afterwards. So that would be the first one. Yeah? The second one, it's mainly how you're shipping the data, how you are enriching the data that you are shipping to Datadog. And that has to do with the tagging strategy. That's really a very, very important point to do as a point number 1, actually. How do we overcome that challenge? At the beginning, when we started using Datadog, when we decided that we are going to use Datadog, we got help from Datadog, from experts. So we had a technical account manager that actually sat down with us 1 quarter, and we defined a very solid tagging strategy that we aligned among all the teams that are developing different parts of the application, microservices or front ends or data. And last but not least is the OKRs. Being able to derive objectives from historical data, it's luxurious, it's perfect. It's like the perfect world, right? Because then you can analyze how you are doing it. You can analyze with those routines how your APIs are performing over time.
Gotcha. Okay. And then are you guys using APM at all for your APIs? And
as of today, we are not using APM because we didn't find the need for that.
Yep.
What we are going to start using are service maps.
Okay, cool.
And with the service maps, we are really looking forward to have that end-to-end observability, including our backends.
Awesome. Any questions from the audience? Don't be shy. If you could, can you go to the mic so that they can hear you? We're also on the live stream too. Yep.
Hello. I have a question about email bouncing. How do you monitor that? Is this a part of Datadog or is it AWS feature?
That's a very good question. And the straightforward answer are custom metrics for that. So AWS and the AWS Simple Email Service, there are metrics but they're not really related to bounces. So what we had to do is basically to engineer a process around bounces where we are basically logging that information, and then we are collecting those and transforming those into metrics in Datadog.
Okay, thank you.
Welcome. I think there was another question here.
Yep.
So my question is that you mentioned that giving the API teams easy to use custom dashboard or something. So is it something like your platforms team develop those dashboards and just hand it over to the API teams, or like your API teams are like also kind of DevOps who actually get involved in the dashboard making, or what they need and all that stuff? But, could you explain on that?
Okay, that's a very controversial question.
Yeah, so the question for the stream is, who is in charge, basically, of building out those pre-built dashboards, and how do you roll them out organizationally?
Exactly, and it's a very controversial question because we had a lot of discussions with those teams, basically. Yeah? There are standard dashboards from the platform teams, because at the end of the day, we are offering platform as a service, that they are made by those platform teams. And what we encourage to the teams that are consuming those dashboards is that if they need, they can always copy and paste the widgets. Yeah, so that's something that they can do out of the box, basically. Yeah? By default, those consumers of those dashboards are not always technical people. They are a lot coming also from the business, so they don't know how to configure those dashboards. So we had a lot of ping pong going around at that point in time. Yeah, like you can configure it. It's super easy to do it because we thought that it was super easy to do it, but actually it was not. And that was one key learning for us. That first, we are not developing the dashboards for them. We are enabling them to develop the dashboards by themselves. And when we were having those discussions, it was exactly at the same point in time when Datadog started with the enablement sessions. And we just enrolled them massively to the enablement sessions so that they were able to build the dashboards. And if they're not able to build sample dashboards, they have engineers that can also build it for them. So it's kind of a shared responsibility model what we have as of today in the table.
Gotcha.
Just a follow-up question, like, did you have any major challenge which you can share while changing this, like having this paradigm shift to start using the dashboards by the API teams or the development teams?
So the question was if we had any challenge.
Yeah, like the biggest challenge you faced, getting this paradigm shift, making the organization level, API teams starting to use these dashboards or move to that model?
The biggest challenge was when our business users, they really like those dashboards, and then the demand really went up in terms of I want to see everything, right? So first we needed to be very clear that Datadog is very good for operations, for technical operations. And we needed to help them and to teach them actually how to develop custom metrics, how to configure custom metrics. And when we showed them custom metrics, they said, this is awesome. I can build really, really nice dashboards using custom metrics. But the logs were not prepared for that. So we also needed to help them on how to re-architect the logs, how to redefine how they are logging, so that they can get metrics, business-related metrics, out of the business logic. And now we are in a position where we have most of our customers in Datadog, most of our internal users of Datadog, that they know how to utilize these custom metrics. And they know how to display those custom metrics in dashboards. So that was the biggest challenge. You're welcome.
Any other questions in the room? Once? All right, again, thank you so much, Santiago.
Thank you very much.
Great question.